Paula from grade 12 ST2A, and I'm here to explain my work using a graphical method.
Gawa muna ng graph and i-state two vectors. So in this case, ang gagamitin natin is parallelogram law because two vectors are joined tail to tail. So, here's my situation. Mikey and Drayton are playing basketball. Mikey heads to northeast in 130 degrees, having a magnitude of 5 meters, while Drayton heads to northwest in 50 degrees with a magnitude of 3 meters to take their positions. So, for A, 5 meters, 130 degrees northeast. B, 3 meters with 50 degrees northwest. So first, we will be using a ruler and protractor to measure the meters and degrees. So first, letter A. So gagamitin ko siya as red. Lalagay natin yung protractor. Then, sabi dito, is 130 degrees. So, here. Lagyan ko ng mark. Then, ruler. 4, 5. So here, this is for A. The next is letter B, so I use blue. So, please aware. First one is 50, so 50. Then line ulit. For 3 meters. This is for B. So, sunod na gagawin. Next, ikakopy natin yung size ng bawat isa para makabuo ng parallelogram. So, yung B, ikakopy natin siya dito. Ayan, sa tail ng A. Stands for B prime. Then copy lang din A. Stands for A prime. So, una, draw the vectors. Then, copy. resultant. So, makukuha natin yung resultant from the origin, papunta doon. Yan. Ito yung resultant. So, susukatin natin siya. Get 5 degrees. Nag-form siya ng parallelogram law. So, parallelogram, ginamit natin. Yun lang.
Hello everyone, so today I'm gonna teach you how to solve vectors. In this video, I will show you how to use component method and get the resultant vector by determining the x and y component of a two displacement. And here's an example of mine. Imagine you were watching a volleyball game and spotted a player that uses two different displacements as her technique. And on the moment you realize her technique, you were only able to witness her first and second displacement. At first, you saw her running 21 meters to north of east at an angle of 37 degrees. And then, you have found that her second displacement is 19 meters long to the northwest at an angle of 39 degrees. In order to sum it all up and get the resultant of the vector, you have to derive the component of each displacement. So now let's start listing all the givens. The given for the first displacement is 21 meter at an angle of 37 degree northeast, and on the second displacement is 19 meter at an angle of 39 degrees northwest. After identifying the given, we can now start graphing. What I'm going to show you is not the final graph, but its purpose is to illustrate the given and help us distinguish what are we going to find. As you can see here, I begin with an angle and followed by the given displacement. After that, I mark the adjacent and also the opposite side. In the same Cartesian plane, I'm going to graph the second displacement similar to the process of the first one. After that, I'm putting labels on every part of the graph. Now that we're done graphing, all we need to do is to solve for the x and y component of the both displacement. After identifying everything, all we need to do is to put the formula and substitute the given. Since we are looking for the x component, we have to transpose it like this and compute the following equation. After that, we have to indicate if the answer is negative or positive by determining its place on the Cartesian plane. After that, we can now proceed on solving the y component. Since we are looking for the y component, we have to use the formula of opposite divided by hypotenuse. After that, I repeated the process that I did on the x component. Now that we've got the x and y component for the first displacement, we can just repeat the process on the second one. Take note that we must observe the negative and positive sign of our answers. Now here's what our graph looked like. After all of that, we can now proceed on getting the total displacement. We always have to remember that the total displacement and its formula must be denoted like this. We must begin on adding the first and second x component to get the total of the x component. Then we can proceed by adding the first and second y component. We can now get the total displacement using the formula that I have shown you earlier. For the last step, all we need to do is to look for the angle of the total displacement. Now that it's all complete, this is how we should write the total displacement and its value. And this is the result of its graph.